Hey guys, so I have an announcement to make. I no longer write any code or do anything computer related. I now have a music channel, so I only play music in my guitar. I quit computers, because of AI and all that. And of course, I'm just kidding. I'm going to talk about LabStore again. This will be our last video on the series. I'm going to talk about how we built a TUI, some challenges we had. I had to refactor this twice, so hopefully I've learned some stuff that will help you if you want to build your own, not to make the same mistakes. And also will tell you about some little quirks that you can hit if you use channels to concurrently update your UI, like in a progress bar, for instance. If you send too many messages, you will produce lag that is only due to visual update. So I'll tell you how to avoid that, and let's get into it. No music for now, okay? So let's begin by taking a look at the end result, so you know what we actually are building here. So this is what we created for our TUI. So we've got 4 main panes. The profiles are essentially your credentials. This uses the same credentials YAML file that we used for the command line interface for the client. For instance, if we select admin, this is invalid, so there is an alert, but let's select the default credentials. And then this will list the buckets. As you can see, you can use the numbers to switch panes, or you can also use tab or shift tab. Okay. And so let's say we select a bucket like sandbox. We can navigate within these files. We can select with space. And let's say that we want to upload some files like contributing, readme, and license. You can press P. This will upload the files. And I also just noticed a slight bug with the progress bar. And this is the issue with designing a TUI. It's really hard work. The tools are not even that bad. It's just the process itself. It requires many small details. So you are controlling everything in here. It's not like web development. This is more complex. It's not harder, but it's more complex. Okay. And so now let's take a look at the code. So the way this works is, so first let's go into CLI TUI. We already had a small component before, which was a progress bar. This was standalone for our command line interface. Okay, so this progress bar was a standalone progress bar, and it's a bit of a special case because we have our main code flow, right? Our program is running. Then we start running a BubbleTeam program, and we communicate with it using channels, but the BubbleTeam program is not the main program. We had to be very careful not to switch control to the main program before the TUI was done, right? Because it needs to have full control of the terminal while rendering the component. But this time we are not doing that. This time we are doing a proper TUI. So this is what we've got under this TUI package. And every component that we have, we split into view, update, and model. And for the root component, this will be our program essentially. So the entry point would be run. In run, we just create a new T program. This new is just a call to a new model over here. And then we use this without screen so that it takes control of the full terminal visually, right? We also enabled mouse, although we still don't have any mouse actions. And then we set with output and with input specifically to this, because in some cases when you are running this on a container or a distro box or whatever, you won't have access to dev TTI, and it will just fail to run, right? So let's go into new. As you can see, new is within our top level model, and this is where we define most of our application logic. So our application state is tracked here. If you've got a context, you can track it here as well. And then we define each of our visual components here. So the 4 panes that we just saw. We also have 2 information panes with just a label and a value. We can have any number of alerts, and these will time out and be removed. We can have a progress bar that tracks multiple files. It's not a multiple progress bars, it's a progress bar for multiple files. We have the status bar on the bottom, and then we have 4 providers that are just implementations to help us access the buckets, access the profiles, access the S3 file system, or access the local file system. We keep track of the focused pane, and that's it. We could, in theory, keep track of the focus for each component individually, but every detail needs to be implemented. There is no high-level API to help you manage all this. There also isn't a Z index, so you need to do compositing, which means you render the string for the full screen, and then you write on top of that string some other string that might be a model or something. And LipGloss still doesn't support compositing, but they are developing it, and it's already on their beta. I tested it, but it's not fully deployed across the whole ecosystem, and I was using some other libs that weren't compatible, so I ended up dropping it for now. It's still in beta, so it's perfectly fair. And so this essentially just instances everything that we need, okay? And then we got an update and a view. The view is just, it's the simplest part of the charm stack, because this is just LipGloss, and as you saw last time on our previous video, LipGloss is just used, to set colors or to join elements horizontally or vertical, or to set borders, set width and heights and paddings and margins and all that. So that's quite trivial. It's your CSS, and as you can see in here, what we do is we just produce the left panes. So if we go back to our and let's go back and forth. If we go back in here, you'll see that we've got the info panel for the bucket, the buckets pane, the profiles pane, and the active profiles pane. And so if you go here, you'll see exactly that. So we've got the info pane for the buckets, the pane for the buckets. Okay, so we do that for the left ones, for the right ones, and of course the width and height will already be encoded within these elements. They also have their own view, and all these widths and heights are saved within their own models, and they are updated within the update function, which is your event loop essentially. And so we've got our top panes as well, which are the left and right panes. Then we render our alerts. We just join them vertical, so the toaster notifications on the right, This is just for the title bar. We fetch the version and all that and create it here. And finally, we create our main view, which is a vertical join of the title bar, that initial line, the top panes, and the status bar. As you can see, our top panes are the left and right panes. Okay, so it's really the middle. It should be the middle panes. And finally, we have our view, and if we have any alerts, they will be rendered on top of that view. So we use this library for composition, or rather compositing, which is called bubbletea-overlay. In LipGloss 2.0, like I said, they will have layers, which is essentially the same thing. But for now, this library works quite well. And so we also render a progress bar if we have a progress bar. And I was just noticing some seconds ago that it was not properly centered. So this composite has some issues with calculations. I'm not exactly sure what I was missing here. I already had to fix this bug. In here I was using from right, and I was just doing -2 over here. There was an issue with this, and I just fixed it. But it seems to also have an issue with centering as well. So, it's not perfect, but I'm not too worried right now since they are releasing this anyway soon. So let's take a look at update now, and this is our main code. In update, you'll have the init, and the way that BubbleTea works is through some kind of, it's like callbacks, So you return these T commands. T command is a function that returns a message. That's it. And we've got ways to combine these commands. Batch will run this in parallel. You also have sequence, So if the second command depends on the first one, you'll need a sequence. So in this case, once we are opening our application, starting our program, we'll immediately load profiles and load the local file system. We won't load buckets because there is no profile selected, and we won't load the remote files because there is no bucket selected. Although in the future we'll save state, for now this is how it's working. So this will run initially, and then we'll move to the update. So internally, the BubbleTea program will keep calling the update function or method for the top level, the root component, and that component is the one that you are passing here to the program. Everything else that you do, any other lower level component, must be updated through the root component. So I made the mistake of thinking that once you create the model, if this model contains other components, then the update for those components will be called automatically. This is not the case. You need to be explicit in calling it. And the first attempt I tried was to encapsulate multiple messages and send them to the top. So every time you send a message, it will be received by the top level update method. No other method will get that message unless you explicitly send it. So I ended up dropping that and doing a lot more updates on the fly, calling directly methods within my components. And that's much easier to do. That's also what I've seen they do the developers for Charm and BubbleTea do when they are coding on their YouTube videos and all that. So something was not making sense to me, and then light bulb went off, and I got it. So one thing that starts happening is this gets too large very quickly. And so one thing I had to do was to refactor any code that I have on these individual cases into their own methods. So what we do on update is we receive a message, and depending on that message, we run some processing. We change our model. So anything that requires data change will be done here. And then we return a command that will update the UI. Usually you don't change anything in the model inside your command, okay? You change it first and then you run the command. If you need to, change something that would make sense to exist inside a command, then you probably need two messages for that. The first one will change the data as you need, and the second one will do some update. So for instance, if we go in here, we've got these messages which are defined in here. And so these are all of our events, let's say, okay? Any action that happens on our application is centralized on this messages package. And so, for instance, we can begin by looking at load profiles message. Once the profiles are loaded, a message with profiles loaded will be sent, and with some entries that we need to update on our UI. If this fails, we'll get profiles failed message instead with an error. And if we, select up, down, enter in a profile, we'll trigger this message over here. So let's test this out, okay? Let's go into updates, and first let's see when we are going to enter our load profiles message, which is done load profiles message, and this just returns the model unaltered, and it also returns load profiles command. As you can see, it is a function that returns t message, and we are just fetching the children for the profiles, so we are getting the profile names essentially. If there is an error, we get profiles failed message, otherwise we'll get profiles loaded message. So let's put a breakpoint here. Let's run our TUI. It should immediately load profiles, so it will hit here, okay? And now it will enter this command, eventually run it, and it will, let's assume it doesn't fail. So let's find this message, and we'll get into here, okay? Let's see. Okay, we got into here and it's still rendering. And in here, as you can see, we are setting the entries for the profile panes. This is outside of our commands. And then we just call the update method for the profiles pane. And this is what I was telling you, this is not automatic. You need to be explicit when calling the update for your subcomponents. And this will return the updated model for profiles pane as well as a command. And we need to run no other commands, so we just return that, okay? And there we go. We have our profiles in here, okay? Just increase this slightly. Also, when I, just out of curiosity, when I increase this resizes. The way this happens is through this t window size message. So you'll notice that I am setting all the dimensions in here. This is where you design your component dimensions, and these must be dynamic. They all come from message width, and then you do some calculations and just set it. So let's, for instance, try to resize this to check whether there is a breakpoint there, okay? And as you can see, there was a breakpoint here. Okay, and this is more or less how BubbleTea works. So BubbleTea is all this update init view, and LipGloss is something that you use within Vue usually to design your components. LipGloss is very accessible. BubbleTea can get a bit complex especially if you don't take care with your architecture, the way you design your application. So now let's take a look at a very specific case, the Progress Bar, which has many quirks. So I already showed it to you, but let's just try it again. Let me go into TMP and just download this. As you can see, I just switched to full screen, so it is centered. And so let's take a look at how this works. If we go into the multi-progress, in here we include the progress from Bubbles. So this is one of the components that we have available on Bubbles, as you can see here. So we've got stuff like spinners, text input, text area, a table, which we use for our local and remote file navigation, the progress bar that I was talking about. We got a paginator, we got a viewport, we got a list, file picker, and so on. Okay, you've got tons of components that you can use. And so we include progress from Bubbles in here. And then we have our width and height for the whole component, because we've got a border around that component. And then we have two channels, one for upload and one for download. And we've got a map where we track the size uploaded for each file, and as well as the total bytes for all files. We just call progress new with the default gradient, and this is just standard stuff. Then we've got our update. The update functions for subcomponents tend to be much smaller and more local. You should think about your application functionality will always live on your top level update for the root component, and only small, very contextual elements will live within their own components. In this case, for instance, when we upload or download, we are just setting the current uploaded or downloaded size to this particular file, and then we update the progress. Updating the progress means that we are going to sum all the bytes uploaded for all the files that we are tracking with our multi-progress, and calculate a percentage, a set percentage for the progress bar, and that's it. The progress bar, because it is animated, there is a frame that is generated. I don't know if it's 60 frames per second. I believe I set it that way. You can set it yourself. And so in here we just call update for the progress bar for Bubbles, and we return that new model for the progress and the command, and it will update by itself. And then finally, the view is very simple as well. We just create a box which got a thick border. Padding is 2 horizontally, I believe, so 2 arguments, vertical and horizontal, so 2 lines vertically and 4 columns horizontally. We use the width that we set on our model, and we align this in the center vertically and horizontally. Then the progress width will be the width of our panel, and we can use this kind of stuff, get horizontal frame size, which is just a way to sum all horizontal space that you spent with the border. So it should be one column for each horizontally for each side, and then for padding we are using again 4 columns on each side. So this should be 2 plus 4 plus 4, right? So 8 plus 2, and this should be 10. You don't do those calculations yourself because you've got these methods already set here. That way you can just mess around with your styles and this will be updated as expected. Now, the interesting part for this is how the progress is tracked, okay? And the complex part is in here. So let's take a look at that. So let's, for instance, look at upload, handle upload progress. And this is how we implemented it. So there is a start upload handler over here, which returns multiple commands. And as you can see, one way to bundle multiple commands is just to create an array and append. You can do it conditionally. And then, for instance, in this case, we are calling tsequence with all the commands. This expands as arguments for the tsequence function. And let's see what we do here. So first we go into our local pane and get our file list. And then we've got a method called marked, which is when you select files with space, this will be returned here. This will return entries for this. An entry contains information like the name, the complete path, whether it is a directory or not, the size, the last modification date, stuff like that. And if there is no selection, then we just return an alert, which is those toaster alerts that you saw in the beginning. Upload fail, no selected source files on local. And then if everything is okay, we just return a message saying that the upload started. We add that to our sequence of commands. And then we create a new progress bar that we set to our top level model, which is where we are, right? And this will begin as nil, and the view won't render anything. If it's not nil, then it will render a progress bar. And we are using half of the width and half of the height of the screen. And we just initialize the progress bar. Before we start uploading, we account for the total size of bytes expected to be uploaded. This is a part of the entry, the array of entries that is returned here. Okay. And then we call our S3 provider upload, and this will return a channel, and this channel is what is used for communication. So it returns the channel, and then we wait for the next upload update, right? Progress update, and so that we can render the progress bar as the file is uploaded. But if we send too many messages, then our file might be uploaded in a millisecond, but the bar will get way too many updates and will waste our time rendering the bar instead of uploading, and uploading will be essentially just locked if we don't handle this properly. So let's take a look at what we do inside upload to handle this properly. Okay, let me see. So first of all, we've got buffer channels. Okay, so we've got two channels here. We got the channel that we return for communication with our TUI, which is a channel for upload progress message. but we also have an internal channel that is used by our client, which is the progress channel. And we essentially just translate the messages from one to the other because this was already being used on our command line interface. And so we didn't want to oversimplify this because these are two different contexts, right? One is for the TUI, the other is independent of any context. It's just a progress channel. So we've got our go routine here, which keeps checking for messages and sending these messages. When it is fetching the messages from our client, as you can see, the file progress channel is sent here. So we essentially just go through this. We start uploading and in parallel or concurrently receiving these messages. And once we are done, then if there is no errors, as you can see, we wait here. We either send an error back or everything is done, and then it will be the TUI that takes care of that last message. And so if we go into put object, in here you'll see that we accumulate or rather in the chunked header, which is the deepest level that handles the progress channel. In read specifically, you'll see that we've got our read accumulator, and we will only send an update message every report progress bytes. Okay, so every 100 megabytes we send an update message. The lower this is, the slower your update will be. Okay. Another thing we take care is to when we, for instance, when we are uploading, we drop any messages if our channel our buffer channel is full. So we use this default. If we didn't have this default in here, it would block until it was able to send. So it would wait for your TUI to render all the tiny progress that it has received, of course, depending on whether you are sending too many messages or not. This might block earlier or not at all even. But this way it will just drop and not send any progress, because remember, the priority is to quickly upload the file or download the file rather than, exactly show the progress for your file. So this is essentially the strategy that I ended up using here to make this more fluid. Finally, just remember that LabStore is now released. Of course, it's the first release, it's version 0.10. I already found a few issues with it that need resolving, like the documentation for the Docker image. It needs more information on how to set up the volumes. Although you can go into our compose file and find a few examples, but other than that, you'll be able to find the release over here on the right. There is of course a ton of stuff here because it's the first release, but at the end you'll be able to find the binaries for Linux, Mac and Windows. Windows just doesn't support start-stop status, but you can run it with serve. We are not really going into deep support for Windows, but we are trying to support the standard Linux or Unix, BSD maybe later, versions that or platforms that are more frequently used. So we support ARMv7 for Linux because there are still devices like Raspberry Pis or older NAS that runs with ARMv7, and so we want to support that. If there is a platform that you like support for, just let us know, because it's probably very easy to just add the binary for that platform in here. I will eventually add binaries for FreeBSD, OpenBSD, and NetBSD at least. As you can see, there is also the assets in here. This is just for the version of LabStore that you install via go install, because it cannot embed the files for the web UI. We still don't have a web UI, but it is planned, and we just have integrated it into the binary for now. And this will be downloaded directly from here if you install via go install. Otherwise, it will be a part of the binary here. Just download it, add execution permissions, and run it. Like I said, there is a ton of documentation here on how to install it. The three main options on how to install this. You can run it with Docker, and in fact, let's quickly test it. I'm not sure if this is. I believe serve is working without a problem, but everything else might have some issues still. This is just a problem mostly with the documentation. But everything will be solved in version 0.1.1. If you have any trouble, hopefully it will be much easier to get it running. And so let's, for instance, try go install. So in here we'll want Illumino Labs, LabStore, CMD LabStore, v10.0.10. Okay. And if you install this version, you should have a LabStore command in your system. This is all unknown because, if you install from go install, there is no way to set LD flags. Or you can simply run it with Docker. And so let me just open outside of my distro box, because I want to run this with Podman directly, no detach. And let's add debug here. Okay, I'm already running this probably from here. So yeah, it's running. Let's just stop it and let's try again. And as you can see, I already had the image pulled, but as you can see, you can run it directly from Podman. Of course, if you want to follow those instructions like I added to the documentation, something like, let's say ls, because I already have a LabStore installed. Okay, not ls. This was dumb. Let's say lab. Okay. So my lab will be running the command from the Docker, but it won't have access to my credentials file, so we've got our credentials file here, and you won't have access to this from Docker unless you mount it as a volume. And so this is something that was missing from the documentation, and I will maybe revise the way that you get this running either way. But for now, the recommended way to get this running is through the precompiled binaries or go install. It should also work fine. But I will take care of the Docker image a bit more in the future, because I want to make it easy for you to run it on your NAS if you like, or something like this. Okay guys, so that's it for the LabStore series. I hope you enjoyed it. I hope the community picks up LabStore. It's not quite ready to be, working as a proper open source project, because it would need testing, but I already updated the contributing documentation. There is a distro box ini under infra that pre-installs everything that you need to get started with development as well. And we will try to open it up as much as we can over time. And I will also encourage you to fork this project as much as you can, because as we've seen before with min.io, and I've heard about some issues with potential issues with some other ones that are being developed that might fall into the same mistakes. We want to keep this open. For now, I don't think I will ever, sell anything around LabStore. But even if we did that in the future, it will remain open, and that's why I want you to fork it, take it for yourself, write code on your repo for LabStore. If you think it's good enough for a pull request, open a pull request. I'll check it whenever I can. I have a lot other projects coming up, so I will take a break from LabStore for a while. But if something comes up that is worthy of attention, I will take a look for sure. Also, there should be a web UI coming up in the future. The person that is going to develop it, who is already on the org, really knows what he's doing. So I'm hoping, I'm waiting for when he has time to work on it, and I will wait as long as it's required, even if it doesn't come, because I want the UI from that guy. And so regarding the channel, I'm going to do some changes, because I'm trying to do too much and I'm getting a bit burned out, and there have been too little videos for the amount of work I've been putting in. So I'm going to change a few things, hopefully for the better. There will be a podcast coming. I have some ideas that I just need to share with the world. And it's much easier just to talk than to code all this stuff. And I'll keep coding and I'll keep working on data related stuff, but I will also do the podcast so I can express myself a bit more freely. We will get back to the data lab infra. I want to implement that the last revision of the architecture from that previous series, and I'll also be working on a few videos on Linux, because I recently came back to Linux. So I used Linux as a desktop for many years back in the early 2000s. I even gamed a bit, but it wasn't great back then. But now that you have atomic distros, immutable distros like Fedora, Atomic, and all the Keynote, and you've got Basite, which is a distro that is ready for gaming. And I game and I develop on my desktop, so I ended up installing Basite, and it's been a very interesting experience so far. I can game fairly well, but I'm more interested in the immutable side of things, and there are a lot of implications in my workflow because I have changed to immutable. So I will be talking about that. I will stop announcing the next video, because I want a bit more freedom on what to do next. But these are some of the ideas that I've got, and stick around if you want to see what the next video will be about, and I'll see you next time.